I'm Yutaro Ueoka from Tokyo, Japan. I'm a member of Yahoo Japan Corporation. Thank you for the opportunity to present our work. Our presentation title is Tackling Cannibalization Problem for Online Advertisement. In this paper, we did 3 points. We defined multiple advertisement cannibalization. We named this MAC, MAC, and we confirmed MAC, and we solved MAC by user modeling technique. This is the content I will talk about. In the first section, I will introduce the cannibalization problem, and in the second section, I will introduce the online ad distribution system and the minor category problem. In the third section, I will explain the BoostMinor model. We developed the model to solve the minor category problem, and as a result, we found the MAC. In the fourth section, I will explain SubtractPopular model and TargetSilent model. We developed these models to solve the minor category problem and also MAC at the same time. Then I will explain conventional cannibalization. Some cannibalization has already been reported, for example, offline-online cannibalization or search ads organic search result cannibalization. AOC is like this. If such advertisements are inserted into the upper section or right section of organic search results, users click these advertisements instead of organic search results and less likely to click organic search results. This means that such advertisements cannibalize organic search results, so we call this problem cannibalization problem. We found another type of cannibalization problem in this work. Second section is online ad distribution system. Our advertisement distribution system has category targeting setting. If advertisers set the category targeting to the advertisements are only delivered to users who are interested in the same categories. For example, Ad 1 have category target for insurance, so this advertisement can only be delivered to users 1 because interest category of user 1 contain insurance. But Ad 1 cannot be delivered to user 2 because interest category of user 2 does not contain insurance. Of course, advertisement categories are selected by advertisers. However, users' interest categories are estimated by our system. So if we successfully estimate the interest categories for users, online ads are delivered more effectively. Now I want to describe the categories. This graph shows the diversity of categories. There are 900 categories, and in this graph, vertical axis is the relative number of impressions, and the horizontal axis is the categories sorted by the number of impressions. This graph is long tail, and we defined minor categories as lower 80 categories. These minor categories have less than 1% of total clicks. Such minor categories have a problem. There are major and minor categories, so minor categories are delivered less likely, and so minor categories have less data, and so this is a negative loop. And so we have the motivation to enhance the minor category and eliminate the negative loop. To solve the minor category problem, we developed BoostMinor model. To generate BoostMinor model, we prepared online questionnaire like this. This questionnaire is for documentary category, which is minor category. Users answered to these questions. Are you interested in documentary, or have you searched documentary, or have you purchased documentary? This data become ground truth data. We thought that the user's answer reflect their interests. So we did logistic regression to estimate users' interest from their search behavior. By this model, we can predict other users' interest for minor category from their search behavior. So BoostMinor model is this logistic regression model, which can add minor category to users' interest category. We test whether BoostMinor model work well or not by this experimental setting. Here, I want to explain how to interpret this result. Target 80 means that 80 minor category, and others mean 820 non-minor category, and all means that all 900 categories. This is equal to the target 80 plus others category. Percent means the gain of the all 900 categories. This is equal to the target 80 plus others category. Percent means the gain of KPIs against baseline model. And impression is the number of times ads had appeared in website. ICTR stands for impression click-through rate and is calculated by the number of clicks divided by the number of impressions. RPI stands for revenue per impression and is calculated by the revenue divided by the number of impressions. For example, we can interpret this red square part like this. By using BoostMinor model, RPI of target 80, its minor category was increased by 5.77% compared to the baseline model. By doing that, we can evaluate the BoostMinor model. Target 80 was strongly enhanced. This is good because BoostMinor model worked well, but other categories were weakened, and all categories were also weakened because depression of other category was too much. This is bad result. And we thought that target 80 category cannibalized others category because users are finite. We thought that multiple advertisements are cannibalized each other's, and so we thought MAC was confirmed. To solve MAC and minor category problem at the same time, we developed these two models. SubtractPopular model is a model that boosts minor category only when a user is unlikely to click major category. For example, user X is interested in only category A, then X is less likely to click other major category ads. So we want to add high score for category A for user X. On the other side, user Y is interested in many categories, then Y will click major category ads. So we want to add low score for category A for user Y. To realize the scoring, we calculate like this. Vector A prime equal vector A for minor categories minus averaged major category vectors. And we use these vectors to estimate users' interest categories. By this calculation, users who are interested in major categories will not have minor interest category. One more model we have developed is TargetSilent. This model boosts minor category only when users express negative attitude toward ad clicking. To find the negative attitude users, we use another questionnaire to classify users into three types. Type 1 user like to click ads, and type 2 user do not have hesitation to click ads but are poorly matched. Type 3 user dislike ads, but type 3 user may dislike ads because they have never encountered to a minor category advertisement, so we want to target the type 3 users for minor category advertisement. We group type 1 and type 2 users. These users have potential to click major ads, so we want to calculate low score for A for user type 1 and type 2. On the other side, type 3 user will not click major ads, so we want to try to deliver minor category ads to the type 3 users. So we want to calculate high score for type 3 users. To realize the scoring, we calculate the vector A as vector A for type 3 minus, vector A for type 1 minus, vector A for type 2. This vector can produce high score only for type 3 users. The last model is BOSS model, which combines SubtractPopular model and TargetSilent model. To evaluate these three models, we did experiment like this. And this is the result for three models. All models are compared to baseline model. And this BoostMinor model result is the result that we have seen in the previous slide. This is just for the reference to remember the previous results. And the result is like that. Target 80 was increased, but others was decreased too much. So total result was negative. This is the previous result. However, in the SubtractPopular model and TargetSilent model, Target 80 category were also enhanced, and others categories were slightly weakened. And this is an important point that others depressions were so weak that all category was still enhanced. This result indicates that MAC was still existent, because others category were weakened, but total RPI were enhanced and mark was reduced. And this is the last result. In both models, every group of categories were enhanced. This means that both models can enhance minor category without causing mark and result in the highest RPI gain compared to the baseline model. This is good result. Thank you for listening.